Everyone, welcome back to Turfgrass Pest Management, Chapter 2. Again, we are following along the Category 3A manual here from Michigan. Here's what that looks like if it will show up. Looks a little bit blurry. Um, but turfgrass, right? Category 3A for us. No doubt some of this information is relatively universal in the management of turfgrass. So if you're from a different state and you're watching this, um, you're going to pick up on good information. I think that the main difference is going to be whether or not you have the same grass type, if you have the same grass type or not. If you're in the transition zone or if you're in warm season turf, that's where we could have some pretty big differences. But as far as cultural management practices go, that's going to be relatively the same for the most part. Um, and again, once we get into the laws, that's when we're going to have a difference from state to state. So that wouldn't depend at all on what grass type you have, but state-wise, I am following the Michigan Category 3A. So without further ado, let's dive into cultural management of turfgrass. And here are the objectives for this. We want to be able to describe various categories of grasses and explain what are ideal for Michigan. Every state is going to have ideal grass types. You guys down in the transition zone, um, you're going to have kind of the best of both worlds or the headaches of both worlds. You're going to have cool season and warm season. If you're down in Florida and you got nothing but warm season, then, you don't want the same grass as we do here in Michigan, right? But also, we're going to want to know the requirements for healthy turf. We're also going to want to identify which nutrients are important to turf and why. Explain the factors that influence the selection of grass for a specific site, and identify mistakes in turf management that can attribute to poor turf or pest problems. Okay, so how problematic growing conditions influence turf grass? Well, this is all of the things that really affect how turf grass is going to grow. We have the species selection. Do you have the right variety for the right place? Um, Quality air movement. Is the air stagnant? Is there no air movement? Is there a lot of air movement? Air movement is going to affect the humidity that hangs out. It's also going to affect the transpiration that's occurring and the drying out of the soil. We also have weather. Is it hot, dry? Is it wet? Is it cold? That all affects the turf. Excessive or deficient nutrients, because too much is a bad thing and too little is a bad thing. We need that right sweet spot. And then what are the pH levels? Right? If our pHs are off, we might have nutrients that are locked out entirely and they're not available. They're in the soil, but they're not available to the plants. What's the soil compaction like? Is it ran over by mowers and cars and it's just compacted to oblivion to the point where, nothing can grow because it's compacted like concrete? You know, that's always a possibility. We have competition like the roots of trees and shrubs, excessive traffic, um, an excessive thatch layer or thatch buildup, sunlight. Do we have enough of it? Are we lacking sunlight? Damage from mower blades, right? If you don't have sharp blades and you're cutting really jagged, nasty cuts on blades, you're making the turf susceptible to diseases. And then we have the incorrect height of mowing. Maybe you're mowing it down to like a half an inch, thinking that you're making a putting green, and all you're doing is making your turf susceptible to everything known in the area. And then lastly, we have irrigation. Now, these are all not in like a specific order of like importance, but all of these are important to grow quality turf. Okay, so these are the baseline necessities for healthy turf. We need adequate temperature, adequate water, adequate nutrition, and sunlight. If any of these factors are not within an acceptable amount, the turf grass will become stressed. Stressed plants are more susceptible to insect and disease issues because their defenses are down. Pretty straightforward and simple, right? So let's talk about water. It is the cultural factor with the greatest influence on turf quality and health. And the reason for that is because too much or too little can make a big difference in a quality turf. Water is necessary to make sugars with the combination of CO2 and light, right, through photosynthesis. It's also used to keep turgor pressure, which means plants are not going to wilt, right? We have pressure within the blades and they don't wilt that way. Um, it also is used to keep nutrients solvent, right? All of the nutrients that those plants need to ride on water. And when there's no water, those nutrients they're not available to the plant. There's also a cooling effect that occurs. So we have transpiration, which is the gas exchange from plants. And basically, they open up these little mouth parts and then they release gases such as, water vapors, gaseous H2O, oxygen, what have you. The relative humidity can be changed due to the plants and the cooling effect of water. Um, Wind, the availability of water can affect turfs, and the ability to release heat. Like I said, that transpiration, that exchange of gases to cool it down. Higher temperatures, more wind, and lower humidity are going to equal greater evaporation. Obviously, it makes sense, right? If it's hotter, higher humidity. If it's hotter, the air can hold more moisture, and so it's going to evaporate as much as possible to a point where we have 100% humidity and then it's going to rain, right? Transpiration lowers the temperature in or near the turf grass, and that's because it's creating a cooling effect within the canopy. That's bright. An example of water cooling turf. So the University of Illinois did a study where they measured the air temperature at 100 degrees Fahrenheit. The canopy temperature of irrigated turf was 87 degrees Fahrenheit. That's pretty wild, right? That's a huge difference. Again, it's that evaporation, transpiration occurring, all of that. But the canopy of non-irrigated turf was 113 degrees. So that's a huge swing as far as temperature goes. When water is limited, turf stops growing. Makes sense, right? If it's one of the most vital things for plants to survive and grow, it's going to need it. And if it doesn't have it, it's going to stop growing. But why does it stop growing? Is because transpiration decreases, the temperature of the canopy rises, and eventually, if there's not enough water, the grass will begin to brown and go dormant. Let's go to the next slide. So temperature, another one of those vital things that we need. Turfgrass species are adapted to specific climate regions, right? And you can check out what zone you're in using the USDA temperature zones. But grasses are mainly divided into three categories. Cool season, which is what Michigan is, where we have Kentucky bluegrass, perennial ryegrass, fine fescues, tall fescues, creeping bent grass. I forgot an N there. Um, and then we have the transition zone, where you have the cool season grasses that can grow there somewhat. And then we also have some warm season grasses that can grow there, like tall fescue, zoysia, and Bermuda. And then we have strictly warm season grasses, which would be zoysia, Bermuda, St. Augustine centipede, and Baha'i. Bahia. I forget how you say that, but Baha'i. Anyway, pretty much if you're in Michigan, all you got to worry about is the cool season grasses. And cool season growth is greatest when air temperatures are in between 60 and 75 degrees Fahrenheit. That's when grass is thriving. If you pay attention in springtime and fall, we get these surges of growth. Mainly in springtime, you'll notice that everything's growing like crazy. All the guys mowing are sometimes having to double cut because everything's growing like 6, 7, 8 inches a week. And then in the fall, the same thing happens because we get into that temperature sweet spot where everything's growing like crazy. In summer, you'll notice that the grass slows down, and that's because it's starting to get stressed. It's out of its ideal zone of temperature. But the best root growth occurs between 50 and 65 degrees. So if the air temperature is 60 to 75, it's very likely that the soil temperature is going to be around 50 to 65 as well. And oxygen respiration increases with temperatures. So food production declines, which is really interesting. But it makes sense, right? They're not making as much food. They're starting to go dormant, starting to, reserve, so to say. High temperatures reduce food production and root growth, which reduces the energy storage to maintain old growth and to produce new growth. So again, it makes sense, right? When we get those high temperatures, those 80s, 90s, hundreds, grasses start to shut down because they can't handle it. Sunlight, another major focal point on turf. All plants require sunlight, to be honest. And that's how they make their food. That's what they use to make their food. But the amount in turf that's required depends on the species or the cultivar. Generally, turf prefers full sun to partial shade. For the most part here, full sun, but there's a select few that can handle partial shade, and they're more ideal for those areas. And you'll notice like on in turf at people's houses and places where the turf is really thin, you're generally going to see the wrong grass species being planted there. Um, but when turf does not receive enough sunlight, it becomes very shallow rooted, very thin canopies, and very susceptible to diseases because of its shallow roots. It also the watering requirements that it needs is a little bit different. And shade, according to the 3A book, um, can be a primary cause of turf issues. And there's a lot of ways that you can introduce sunlight. Um, it's not like you can harness the sun and bring it down to it, but if there are trees, maybe you could recommend to your client to do some thinning of the tree, not lines tailing, not like you're limbing everything from the bottom up, but selective thinning of the canopy. A quality arborist would know what to do if the goal is to get more sunlight down to the turf. All right, so soil and pH. Soil conditions influence plant development substantially. We're talking about moisture, air, nutrient availability. Construction can damage or destroy soils from compaction. Soil takes years to develop, and generally speaking, um, in new construction, what happens is we strip the topsoil layers away, and we basically leave it at hard pan or really crappy soil once a new home's there. And so the soil biome is just completely messed up. And that's why a lot of new turf stands take a while to develop. It's because the soil is not what it should be. Um, and what is soil composed of? Soil is composed of inorganic particles, organic matter, water, air, and soil organisms. The ideal soil conditions contain 50% organic and inorganic solid particles. Think clay, silt, sand. And then it has 50% open pore space. Um, that would be wide open areas, cracks, crevices for water and air to fill. Okay. So just envision, you got I don't know, a bunch of dots on you're compiling them all together, little circles, but there's these little gaps in between all of them, right? That little space is for water and air to fill. And here's some good examples, right? I'm actually going to move myself over here because I think I'll get out of the way. So this triangle here is showing us the basically what soil is and soil structure and soil makeup. We have clay, we have loam, and we have sand, silt. Um, Sand is the coarsest particle. And when I say coarse, it is the largest particle. And so it's very difficult to take sand and make a ball of it. It's just going to fall right out, right? It's coarse. It doesn't want to stick together. But clay, on the other hand, is really fine. And so you can make clay balls very, very easily. Clay is really susceptible to compaction. And when it's compacted, it limits water and oxygen down to the roots of the turf, trees, shrubs, you name it. So a lot of soils here in Michigan are clay, and you'll notice that when they dry out, you start to see like surface cracks, and that's because all the soil's swelled together like this. And it takes a long time for that to fix itself. Now, on this other chart, we have pH and nutrients. And ideal for turf is going to be in between that 5.5 to 7.5. If you want to be more specific, 6 to 7 is really, really good for turf. And it's also one of the top places in the pH scale where the most nutrients are available. So we want to aim for that. Most soils here in Michigan are over 7. Um, so, it's really hard to change soil pH over time. Really, really hard. So, but if you had to, if you wanted to attempt to change the pH, you would use lime to increase the pH. Generally, on lime bags, it'll tell you how many pounds per square feet or 1,000 square feet. It's a lot. And then we also have sulfur, which is to decrease the pH. Here in Michigan, I doubt you're going to have to add lime. If anything, you're going to have to add sulfur, and that will take a long, long time to adjust. So we got to be mindful of this. And, you can't do everything, right? All right, move me back over here. Okay. So nutrients, the percentage of clay and organic matter determine the nutrient holding capacity because those are what nutrients bind to. Um, Nutrients are in constant flux in soil, so it's a give-take relationship, right? Plants take them out. It's constantly being re-added through thatches, leaves. Soil organisms are breaking down new material all the time, so it's constant flux. Fertilizers are marketed with varying amounts of 16 mineral elements that the turf requires or any plant requires. And soil tests are critical to understand the nutrients of the soil and the potential deficiencies on the properties that you go to. So it's always recommended to take soil tests. Um, Honestly, annual soil tests or every 2 or 3 years is ideal. So that way you know what's going on and what you need to replace. The basics of nutrients are nitrogen, phosphorus, potassium. That's what you're going to see on most fertilizers. They have an NPK ratio, and those are the three numbers that are displayed. And then it'll generally tell you what are the micronutrients uh, later, somewhere on the bag, on the label. But what those numbers actually represent when they're talking about the NPK ratio is the percentage of that nutrient in that bag. So a 12-12-12 is actually 12% nitrogen, 12% phosphorus, and 12% potassium. So that contains all of the main nutrients that plants needs, and then there's micronutrients that we're going to talk about here in a minute. But nitrogen is essential for plant growth, and it's also the largest quantity-wise that turf requires. This is really crazy. I didn't really realize this until I revisited the 3A book, but dry turf clippings contain about 5% nitrogen by weight. That's wild to me. Um, Nitrogen deficiencies are generally a poor color, poor elasticity in the leaf blades, and density of the turf. Some nitrogen is consumed by soil organisms, and then some is lost through leaching. So all the nitrogen that you throw down might not necessarily make it to the plants. It's got to go through some other channels first. And then nitrogen is also what the turf responds to the most. More than any other nutrient out there, you throw down nitrogen, that turf's going to respond. It's going to grow. It's going to grow really, really quickly. And the rule of thumb is to not exceed 1 pound of actual nitrogen per 1,000 square feet in a single application. Too much nitrogen can result in unhealthy turf, shallow roots, increased diseases, reduced drought tolerance, and reduced wear tolerance. And the greenest lawn is not necessarily the healthiest lawn. I will also say that trees and shrubs are also affected by the applications of nitrogen on lawns. Whatever leaches down into the ground hits the trees, and then those trees can grow excessively, and then they can be susceptible to insects and diseases. So we got to be mindful with how we're using nitrogen. Phosphorus. It's vital for root development, maturing, and seed production. So generally, when they're going into seed, they're using the most phosphorus, right? In nature, it's bound to oxygen, which the ratio would be P2O5, which when you type it out on a computer, it's very difficult to make those how they actually should look. A few soils are deficient in phosphorus here in Michigan. Applications should be limited with the exception of newly established turf. MSU Soil and Plant Lab state soil test with 15 parts per million is adequate for turf here in Michigan. Deficiencies shown through purpling of grass blades. Similar changes could occur with cold weather. So just because you see purpling grass blades might not mean that it's a phosphorus deficiency. And then phosphorus binds to soil pretty well. So when erosion occurs, it can carry a large amount of phosphorus with it. This can create negative impact on surface waters and the environment. Excuse me. And you'll notice a lot of algal blooms from the phosphorus, and that's something that is probably one of the main reasons for Michigan making a law in 2010, which was passed banning the applications of phosphorus to turf. That law specifies that phosphorus may only be applied if within 1 year of the turf being sodded or seeded, or within 3 years of a soil analysis indicating a deficiency. So we saw an issue, and if we were over applying phosphorus and what it was doing to the environment, and so we made a law saying, hey, you can't do that unless it's a very specific situation, which they already said that most soils are not deficient in it, you know? So why should we apply it if we're not deficient in it? Just makes sense, right? Potassium. It's the second main nutrient after nitrogen. Okay, it's vital for rooting. It improves traffic wear and climate stress. So if you have crazy swings of weather, potassium will help. Um, it's rarely obvious as a deficiency. Blades begin to yellow and they have dead blade tips. Even if a soil test indicates potassium levels are high, it might not be available to the plant, and that's all due to pH or not being soluble or being locked up in some way, shape, or form. Routine applications of potassium at a ratio of 3 to 2 with nitrogen is beneficial, and applying potassium will not produce a dramatic green upper growth effect. So this one is one of those nutrients where you're not really going to see a big change if you do apply it. All right, so let's talk about micronutrients. So let's talk about micronutrients. These are used in relatively small quantities by plants, and the Michigan soils typically contain sufficient amounts of micronutrients. Higher pH can make these elements insoluble. So we do have higher pHs here in Michigan, and so some of these might be locked out. But I don't think it's necessary for you to apply micronutrients. I don't think it's really called for. Um, but it can make them inaccessible to the plant, right? Iron is typically locked up and unavailable at high pH soils greater than a pH of 7. So if they're not getting iron, they might show a deficiency. You might have to do a sulfur application or something like that to try and get it down. But like I said, changing the pH of soil takes a long time. If you can change the pH like 0.2, 0.3, that's a lot. Okay. Um, but it's required for chlorophyll production, roots, shoots, drought resistance. Um, Turf deficient iron is usually blotchy yellow. Severe deficiencies result in white blades of grass and death of the plant. Now, I've never seen that, but apparently it's a thing. Iron applications result in darker greening of turf blades. So if you want a quick dark green up, apply some chelated iron to a lawn, and bam, it'll get super dark. Soil organisms. So both living and decaying organisms contribute to healthy turf. They do that through the organic matter and they make the soils more fertile. Living organisms break down organic matter and make nutrients available for plant uptake. 1 teaspoon of soil contains about 1 billion bacteria, 1 million fungi, and several thousand algae. This biome can be destroyed with the overuse of pesticides and fertilizers. So we really need to be conscious when we're applying Excuse me. Yeah. I got this cough. I'm trying to get rid of it. The biome can be destroyed with the overuse of pesticides, right? So we got to be conscious of the pesticide use that we do, and hopefully we're not going to destroy that biome. So establishing turf, how do we do it? Well, we need to select our grasses, right? We select them based on the pest susceptibility, the compaction tolerance, the soil type, tolerance of shade, tolerance of drought, traffic tolerance, Um, Cultural intensity tolerance is what they wrote in the book, but really that means maintenance. What kind of maintenance is it going to incur? What kind of thatch layer is it going to create? What's its fertilization preferences and what's its preferred mowing height? All of those things we need to take a look at before we select the right grass for establishing a turf. A turf that is diverse in species and cultivars is generally going to be less susceptible to pests and diseases. Just like anything, right? If you have a diverse forest, a diverse garden, you're not going to have too many issues. And that's because there's greater genetics. There's a lot more genetics in that area. It's going to have a better biome, more microbes. There's going to be a whole web of things that are good. Um, and when you have more species, it can adapt better to environmental conditions. This is why when seed is sold, it's sold as a blend. And they mix these blends because they know they work well together. They play well together. Um, Kelly, Kelly, Kentucky bluegrass will dominate in full sun areas, and perennial ryegrass will dominate in shaded areas. Man, I missed an S there. What the heck? Quality seed is worth it, but it is expensive. If you ever looked at grass seed recently, you know how expensive this stuff actually is. So, certain fescue and ryegrasses contain fungal endophytes. They're naturally occurring fungi. It doesn't harm grass, but it acts as a biological control to chewing insects, and the fungi secretes a toxin. But this type of grass should not be used for foraging because it can be harmful and damaging to livestock. So again, we got to be conscious in the grass types that we choose. That's bright. So let's walk through the planting procedure and what we need to do. A lot of problems can be avoided in turf if the proper planting procedures are followed. So this is really critical to know. Um, First, we want to apply a systemic, non-selective herbicide prior to planting. So if we have a turf stand that we're trying to renovate and make a new turf stand, we want to kill everything that's in there. And obviously, we want to check the label for the recommended interval prior to seeding because it doesn't make sense if you're going to plant something prior to that and the herbicide is just going to kill it. We need to rough grade the area, amend the soil with whatever amendments you plan to put. Take a soil sample so that way you know what kind of nutrients you're dealing with, what kind of soil it is. You want to plow, rototill, or disc the soil to a depth of about 6 inches. Remove the stones and the debris. Put a final grade and fill in the high and the low spots, or remove the high spots and fill those low spots in with what was left over in the high spots. And then you want to apply and rake in a starter fertilizer. Um, that fertilizer is based on the soil analysis that you got earlier. Plant the seed or the sod. Ideal time to do it is in the fall. The reason is because we're coming out of the heat stress moments and we're going into a cooler temperature. And when we're doing that, those roots will be able to take hold a lot easier. If you were to do this in springtime, we have a cooler time frame right then, but then we stress everything out in the summer. We got to water it like crazy. So fall, we're doing pretty good. We're going into a cooling effect, and then by next year, the turf will be pretty established. Um, but you want to lightly rake that seed bed to cover the seeds with some soil. Either apply straw that's weed free or peat moss. I'm more partial to peat moss than straw. I think peat moss looks nicer than straw. Um, and then we want to water that newly planted material thoroughly and carefully until the grass is fully established. If anything dries out, it'll cause a significant loss in the turf. But overwatering could cause runoff and seed accumulation in low areas, and you'll have these bare spots. So all of these things are critical when you're going to establish a new turf. Let's talk about the post-planting care, okay? Watering. The amount and frequency will depend on weather conditions. And it makes sense, right? If you're going to have a ton of rain, you don't need to irrigate. It's going to be fine. Um, but if it's going to be dry, then you do need to irrigate. And you need to keep the area moist, but not soaking wet. Because what can happen is if you make it soaking wet and over irrigate, you can cause a dampening off effect. And that's when germination occurs, but then rot will occur on the seedling and it'll die. So we don't want that. So as the seeds develop, we want to dial down the watering so that way that dampening off doesn't occur. And then as far as mowing goes, you mow when the turf has achieved the desired growing height. So if it gets up to like 6, 7, 8 inches, it's good to mow it back down to 4, and then you keep maintaining it. You want to make sure the blades are sharp because the dull blades could pull plants out of the ground or make jagged cuts. Those jagged cuts then make the plants susceptible to disease. So let's talk about fertilizing, which is kind of different than trees, which is kind of more my specialty. But we do want to perform an application a couple weeks after germination. It's a very low application, like a 2-1-1 or a 1-1-1, and you don't want to apply more than 0.5 pounds of nitrogen per 1,000 square feet. You want to water immediately after you apply fertilizer so that way you uh, don't risk the burning of the delicate seedlings. And then what about pest management? Right? What do we do that? How do we do that? And what do we deal with um, for a newly established turf? Well, it's not really wise to apply pesticides during establishment because you could cause damage. You could cause, potential harm to the seedlings. And then if there's weeds growing, ideally you could just pull them out if you've done your job correctly and you have quality soil and it's rototilt and you killed everything. Um, but otherwise, just wait until everything's really established and then you could spot spray. It's more ideal. Ooh, look at that golf course. Look at that turf. Doesn't it look nice? It looks nice to me, man. I really respect golf courses. Maintaining turf is no doubt the most costly when it comes to landscape management. Turf is maintained on the basis of aesthetic value and its use purpose. So a golf course like this, way more maintenance goes into that than the average residential home. That costs a lot of money to maintain that. But look at the aesthetics of it, right? It's beautiful and it has a high use, right? We can see all those little divots from, I'm sure that guy probably made a divot that's standing right there. We don't see it flying in the air, but I bet he did. Um, and then the turf along freeways has the lowest value, right? It's just there. It's just a border. Surprise, it's not concrete. In some countries, it is just concrete and they don't have turf. So, management practices reflect tolerances of turf grass species. In Michigan, Kentucky bluegrass is the preferred grass for lawns. Um, Primarily, you're going to see Kentucky bluegrass everywhere. Um, Now let's talk about watering an established turf. What does it require? Well, generally speaking, natural rainfall is usually adequate in the spring and fall, but summer drought and heat can cause stress on the turf. So we might have to um, implement watering and irrigation in the summer. There's a term called evapotranspiration, and that is the measurement of turf's use of water. It's evaporation of water plus what is used in transpiration. Cool season lawns generally require about a half inch to 1.5 inches of water a week, which is surprising because you watch people's irrigation systems and they're laying down an inch a day. They're throwing it down. But again, that all depends on the weather conditions, right? If we have a ton of rain, shut the irrigation off. If we don't have a ton of rain, well, might want to turn that irrigation up. Look at that nice soccer field. Doesn't that look nice? Nice, nice grass. So, what does the MSU research say? Insect and disease damage is reduced when light, frequent irrigation is used. So turf really likes light, frequent rains. In contrast to trees and shrubs, which prefer infrequent, really deep waterings. So if you have a mixture of the landscape, each little zone is going to have its own watering requirements. Um, and then that watering, the amount that it needs can vary. You could get the right amount down into the root system in 10 minutes, or you can get it down there in 60 minutes. It really depends on what the soil um, is made up of, the texture. Is it clay? Is it sand? What's going on. But you can find out how much water you're throwing down very easy. Just put rain gauges out there on the lawn, in the turf, or tuna fish cans work well too, the old tuna trick. And you can figure out how much water you're putting down in your irrigation. The ideal time for irrigating a lawn is in early afternoon. And why it's the most ideal time is because it takes advantage of the cooling effect. So we're coming into early afternoon, just past the hottest part of the day. We cool our turf, and then it sits there, and it'll stay moist all throughout the night and then into the morning. Um, However, local governments might have a limit on the amount of water that you use and apply, right? If you've ever looked out at California, they have very strict watering limits. So it all depends on where you're at. So let's talk about mowing, which this turf over here, I mean, good grief, that is super low, right? It's a beautiful carpet on a putting green. Um, it's one of the most important cultural practices for turf management. And the reason is because if you mow correctly, you can create a dense canopy that's uniform and vigorous. It's also the most costly, right? If you think about it, we have mowers, gasoline for the equipment, the labor, the blades, the maintenance of all that equipment, the trailers to get it there, the trucks to get it there. It's very expensive to mow, surprisingly, and it's a relatively cheap service that's offered out there. Um, Low cut turf, like greens and fairways, require more care, which makes sense, right? They're more susceptible to weed seeds germinating, possibly some disease occurring, things like that. Um, High cut turf, like a residential or commercial location, it's going to require less care, right? You're going to put it at like a 3.5 to 4 inches, and it'll look great. You know, if it's not a golf course, it is ideal to mow the turf high. Like I said, 3 to 4 inches is perfectly fine. I find 3.5 to 4 inches in my turf to be the most ideal. Um, Otherwise, you're starting to scalp it and then you stress it, and it's not good. But ideally, we want to mow when the turf reaches about 4 to 6 inches. And that's because there's a rule that's called the 1/3 rule. You only want to take off 1/3 at a time. And that's pretty difficult to do in the springtime when it's growing 6 to 8 inches a week. If you want to keep grass at 3.5 inches and it grew 7 inches or 5 inches, and you got to take it back down, you're breaking that rule a lot. And if you can follow that rule, you're going to avoid a lot of stress on that turf. And then the rule for droughts is to mow less frequently because you're going to avoid stressing out the turf. Because it's going to have to put energy and water and resources and nutrients into regrowing itself. So let's have a debate over some uh, clippings. All right, so what's pretty interesting about clippings of turf and grass, and I found this fascinating that it was in the book, was that if you remove the clippings from mowing, you're going to have an increased fertilizer usage in between 25 and 50%. Mind blowing. So, again, we learned earlier that, there's 5 pounds or what is it? 5% nitrogen by weight in grass clippings. And so, if you were to leave that, let it turn into thatch, let it break down, let the soil organisms do their thing, you could reduce the amount of fertilizer that you apply on a lawn. But in certain instances, you might want to improve the appearance. Like at a golf course, they might want to remove the clippings because they don't want their patrons to walk around and carry clippings on them. That's just, not ideal. But removing clippings isn't really necessary in most cases, right? Most people worry about thatch, but it breaks down and returns as nutrients. Um, and there's some cases where thatch can be an issue. I think it's generally when it's over 0.5 inches is when they consider thatch to be an issue, and you should think about removing some. And interestingly enough, in 1993, Michigan made a law that forbid landfills to accept yard waste. Wild, huh? Who would have thunk? Which kind of forces people to leave the clippings on the yard. In some situations, some people might want them removed and then they got to be taken to a special place, like a composting place. But I think a lot of people here in Michigan leave the clippings on the yard. And if they're excessive in clippings because they didn't get to mowing correctly or weather conditions prevented mowing, then we just double cut. So that way the clippings are finer and they'll go down into the thatch layer easier. Um, but there's one condition when removal would be ideal, and that's if there's disease and you want to remove some of the inoculum to reduce the potential spread. That is a cultural practice, removing the clippings, and it does indeed work for that. So let's talk about fertilizing, which is a huge role in a cultural practice. and maintaining high quality turf. Um, Generally, people follow a holiday fertilizer plan, which is 1 pound of nitrogen per 1,000 square feet Memorial Day and Thanksgiving, and a half a pound of nitrogen per thousand on the 4th of July and Labor Day. And apparently, that's been a method and plan that's worked quite well. But again, fertilizing should be performed on a prescription basis, right? So you need a soil analysis and it'll tell you what you actually need to put into the ground. So fertilizing continued. This is a picture from the 3A book, and it tells you kind of what materials there are for nitrogen, phosphorus, potassium, iron, and if they're organic or synthetic, um, if they're acidic or an acidifier, if they're water soluble, if they're slow release, what's the burn potential of them. This is a very, very good table to look at. Applications of nitrogen when turf has weak roots can cause stress because you're pushing the plant, you're telling it grow, but it doesn't have the root system to support itself or to acquire enough water, right, to support itself. There's a couple different types of fertilizers. We have quick release, which is highly soluble. Think of like a urea based fertilizer. I know on that table it says ammonium nitrate is a high potential of burn because it's highly soluble. Um, and there is a risk of burn when you use quick release. Slow release, though, is either organic or it's coated to be slow release. Now they have fertilizers that are coated so that way it's releasing very, very slowly, but it does produce really good results. Organic or coated and slow release is more expensive, but again, you're going to have better results. So is it worth the money? You got to make that up for yourself, right? A complete fertilizer contains nitrogen, phosphorus, and potassium. Okay, that is complete. A balanced fertilizer contains equal parts. So, like in the previous example where I said a 12, 12, 12, that is complete and that's also balanced. Um, but just a complete fertilizer is just it contains nitrogen, phosphorus, potassium. So I just want to make the difference there. If you were to take a bag that's a 25-10, again, those are the percentages of these elements in the fertilizer. So if we have a 100-pound bag of fertilizer, it contains 20 pounds of nitrogen, 5 pounds of phosphorus, and 10 pounds of potassium. Now, if you were to apply 5 pounds of this fertilizer over the course of 1,000 square feet, it would be the equivalent of 1 pound of actual nitrogen per 1,000. Again, it's 20%. So 20% of 5 is 1, right? 1 pound of nitrogen, etc. So the math's there. Math's easy. We're going to talk about calibration and math further in this series of the Turfgrass Pest Management. So let's talk about fertilizer burn because this can happen. It usually happens when heavy rates of highly soluble fertilizer are applied, and it's due to the ground being frozen, wet foliage, or hot weather. How do we avoid fertilizer burn? We don't want to apply fertilizer when the turf is dormant or stressed. We also want to do even applications. We don't want excessive fertilizers applied in certain areas. You don't want to spill your fertilizer on the turf because that could cause some issues. You want to apply it to dry foliage so that way the little granules don't stick to the water and then burn that blade. You want to apply granule or pelletized formulas, not necessarily a spray formula. And then you want to water in soluble material. Um, so if it is a highly soluble material, make sure that irrigation runs so that way it pushes it down into the ground and off of the actual grass blades. You could also use a slow release or insoluble forms of nitrogen. And again, the max rate that we want to apply at any one time, any one application would be 1 pound per 1,000 square feet. Let's talk about aeration, some core aerations. This is a fantastic service that can be performed to enhance turf. Um, it does aid root system development. It reduces compaction in heavily compacted soils. An ideal time to apply seed or to fill in a dense turf stand. So generally this is considered an aeration overseed. While it's being aerated, seed's being applied. That seed ideally makes its way down into the holes, into the cores that you've pulled out, or the holes of the cores that you pulled out, I should say. And it can fill in and make the turf a little bit more dense. Um, Overall, it's going to increase air and water down into the ground, into the root systems, which is where we want it. And fall is the best time to perform this service. The soil is a little bit softer and it's better for germination of seedings if you're going to do an overseed. Let's talk about dethatching. So dethatching, like I said, it's um, thatch is generally not going to be an issue unless it builds up to a certain point. Um, it's made up of dead blades, stems, leaves, roots. Small amounts are beneficial to turf. They reduce compaction. They moderate the temperatures of the soil and somewhat the canopy. It limits the evaporation of the soil because it shades it out and creates a layer. Too much thatch, though, could restrict water from getting down to the ground. Same thing with air movement. It could restrict air movement. Um, could encourage disease or insect pests. And applying large amounts of nitrogen is going to increase thatch buildup. And why that is because you're going to push those plants to grow more. You have more blades, thicker blades, wider blades. You got to cut them, and then it builds up. And then over irrigation or poor mowing practices can also contribute to excessive thatch. But if the thatch is thicker than 0.5 inches, we should think about taking steps to reduce it. Because beyond that, it's going to definitely cause some issues with turf. So let's talk about some turf and shaded areas. And this is a great picture. Nice little park, some massive trees, and then we got some turf below it that's really, really sparse. Why is that turf sparse? Because turf likes sun and trees are competitors. That tree is definitely taking over the sun and that turf is thinning out. Um, so if we were to fix this situation, there's a couple things we could do. We could make a mulch bed for that tree that's nice and big so we don't have to worry about the turf. We could do some selective pruning up in that tree to let more light down into the turf area, or we could plant some shade tolerant species um, like rough bluegrass or fine fescue. Those will do very well in shaded areas. Tall fescue and perennial ryegrasses do okay. They're not going to be the best. And then Kentucky bluegrass, not ideal. It likes sun, so do not plant it in a shaded area. And that, my friends, is the end of chapter 2. And I hope you got some value out of that. I hope it's going to help you with your exam if you're taking the exam. If not, I hope it helps you, by getting CEUs for this. It's all about turf grass, right? We got to talk about turf grass. Need turf grass credits if you have the turf grass license. Other than that, I will see you guys in chapter 3. So you take care, and I will see you there.